Question 6 from exercise 11F. Now we're given that y to the half is x to the third plus 3. And we need to show that y is equal to x to the 2/3 plus ax to the third plus b. And this is where a and b are constants to be found. Now the trick is here that realising this is the square root of y. If we want to get y, we're going to have to times, what we're going to have to do is we're going to have to square that to give us y. Now if we square one side of the equation, we've got to do the same to the other side. So we've got to square x to the third plus 3. So we've got to remember that that is x to the third plus 3 multiplied by x to the third plus 3. Now expanding our brackets, that gives us x to the third times x to the third. When we multiply, we add the powers, so x to the 2/3, which is what we've got here, so that's good so far. We're going to have 3x to the third and another 3x to the third, and then 3 times 3 is 9. So simplifying, we've got x to the 2/3 plus 6x to the third plus 9. So a is 6 and b is 9. Now in the second part of the question we've got to find the integral of y with respect to x. This is part B. Integral of y with respect to x. So y is what we've just worked out. It's all this lot here. So x to the 2/3 plus 6x to the third plus 9 with respect to x. So when we integrate that, we get x to the power of 5/3 divided by 5/3 plus 6x to the power of 4/3 divided by 4/3 plus 9x plus our constant, because it's an indefinite integral because we've not been given limits of integration. So tidying that up, that's going to be 3/5 x to the 5/3 plus 6 times 3 is 18, so 18/4, which I'm actually just going to simplify straight away to 9/2 instead. X to the 4/3 plus 9x plus the constant. So part B is done. Now C says, using your answer from part B, determine the exact value of the integral between 1 and 8 of y with respect to x. Now we've already performed that integral, the indefinite integral, and we've got this. So what we've got to do is we've got to take this and evaluate that between the limits. So we've got to take 3/5x to the 5/3 plus 9/2 x to the 4/3 plus 9x between the limits 8 and 1. Now at this point I'd reach for your calculator because I don't know off the top of my head what 8 to the power of 5 is. Or alternatively, if you were to do it without a calculator, what you could do is you could find the cube root first and then take that to the power of 5. So we'll have a go. So, when I substitute 8 in, cube root of 8 is 2. 2 to the power of 5 is 32. So we're going to have 32 times 3, which is going to be 32 times 3, which is going to be not 6. It's going to be 96, isn't it? 96 over 5. Now you can see why Core 2 is a calculator paper. Cube root of 8 is 2. 2 to the power of 4 is 16. 16 times 9. Yeah, I'm just going to get the calculator at this point. So 16 times 9 is 144. So 144 over 2 is going to be 72. And then 9 times 8 is 72. And then we're going to be substituting 1 in. That's nice and easy to do because 1 to the power of anything is just 1. So it's 3/5 plus 9 over 2 plus 9. So now if we tidy that up, so for our first bracket for substituting in 4, we get the answer 163 and 1/5. And when we tidy up the second bracket, we get 14 and 1/10. So tidying all that up now, we get 149 and 1/10. That's the question done.